Good evening everyone, myself Gautam Sharma. I welcome you all in a Sapiens Education. So today I am going to discuss about the diffraction of the wave. So this is part 5th of the video. So I will discuss each and every part, everything here. So what is the basically diffraction of a light wave? So it is the phenomena diffraction. If you want to write, so it is the phenomena. It is the phenomenon of bending of light, of bending of light, of bending of light around around corners of obstacles or aperture in the path of the light. In the path of the light. On account of this, bending of light penetrates into the on account of this bending of light penetrates into the geometrical shadow of the obstacle. Geometrical shadow of the obstacle. Now let us see here. This is the wave of the light and it is the wave front. It will come. So this is the slit is opening. So after this it has to make a light like this. So it has to make light like this, but due to diffraction pattern, what happened, this wave will be created like this and it will able to penetrate this. So the brightness should be here up to this, but it will spread over this area. So this is known as diffraction. Again I can take another example. If light is coming like this and if we have done some sort of obstacle we have created, so according to this the light should make a brightness here only, but due to its wave in a nature, so what happen, it will penetrate the shadow. So these are the shadow part, these are the shadow part. So this phenomena is known as diffraction of light. I hope you have understood this. Now let us consider about diffraction of light in a single slit. Now according to the Huygen principle, each point on the plane wavefront, let us see that each point on the plane wavefront, see, this is the light source and this is the lens for it, and when you put here light source, so what will happen, this wave will form, wavefront will form. So these are the wavefront, okay, wavefronts will form. So when it enter to this slit, so this is the plane wavefront AB, right? So AB, so what happened, according to the Huygen principle, each point on the plane wavefront AB sends out secondary wavelet in all directions. Secondary wavelet means these are the secondary wavelets. So it will send in all direction, right? All direction. Now the secondary waves from point equidistant from the center of the slit lying in the position CA and CB of a wavefront travel the same distance. See, this wavelet will travel the same distance. See here, when it will travel the same distance, so what will happen, when it will travel the same distance in reaching O, and hence the path difference between them is 0. There is no path difference. See here, same distance has been traveled by this both source. What? So that's why path difference is 0, so intensity will be maximum. Okay. Now let us consider a point P. Let us consider a point P, right? So this is a point P. This is a point P, right? So at this point P, at this point P, at this point P, this light source is coming like this and another is coming like this. So what is the path difference? So path difference will be how much? So basically we know, we have already done in earlier, that path difference. So path distance difference will be this one. So this has to travel this distance and this light has to travel this distance. So this extra amount of distance is Bn, is considered as a path difference. Path difference. Okay. And this point where the next bright fringe is making, so this point is at a distance of y, at a distance of y, right? Now from here we can also say that path difference, that is Bn, path difference, that is Bn can be written as, Bn can be written as a sine theta. Now you are thinking what is a sine theta? So let us take this. So this length is this length of the slit is a. So this will become a sine theta. And since it is your constructive interference, so what will happen? This path difference can be written as n lambda, right? N lambda. So finally we have got as a sine theta is equal to n lambda. So this is one of the equation which is very important. Got it? Why I have put here a sine theta is n lambda? So a sine theta is your path difference, and this path different for see, for minima, if you want to find minima, so you can write here n lambda, right? So basically path difference is equal to n lambda, that is a sine theta is equal to n lambda. So we can say that the position of the we can say that position of the position of secondary minima, that is equal to path difference for secondary minima is equal to a sine theta, and this is equal to n lambda. So from this equation we can find n is equal to a sine theta by lambda, or we can also find any one. Okay, I hope you have understood this. Now we will go for position of the secondary maxima. So for secondary maxima, the path difference for secondary maxima, path difference is equal to path difference, we have already done these things. Path difference is equal to 2n plus 1 into lambda by 2. But at the same time, for this diffraction pattern, what we have arrived, that path difference is equal to a sine theta. So path difference can also be written as a sine theta. So from here, a sine theta is equal to 2n plus 1 into lambda by 2. So this is the relation what we need to understand. Okay, so I hope you have understood this. Now let us consider intensity or distribution of the diffraction. So as we know that this is the diffraction pattern, and they said this is your lambda by 2, and this is 2 lambda by d and 2 lambda by d, right? So at the maximum point, see here, maximum, when we talk about this one, see at this point the brightness is maximum, because brightness is maximum at this center. After that, brightness intensity will be get reduced like this, okay. And this length is known as the width of the central brightness, width of the central brightness. So these are the intensity distribution curve. So if you want to know about the intensity distribution curve, so you can write like this, or we can sometimes like we may write like this, uh, 0 lambda by d. So let us take a example, or let us make a draw the intensity distribution curve. So when we draw the intensity distribution curve, so what will happen? We will have this intensity will be vary like this. After that, this will be minus lambda, this will be plus lambda. Now this will be 2 lambda, this will be minus 2 lambda. Again this will be minus 3 lambda, and this will be also plus 3 lambda, right? Now you are thinking that where we are getting, see here, maxima point. So see here, we will get maxima point when it has a path difference of 2n plus 1. So let us suppose first maxima we want to find. So n is equal to 1. So this will be 3 by 2 lambda. Got it or not? So this is maxima, and minima point means n lambda. So n lambda means n is equal to 1. So minima, you will get minima at lambda. So minimum intensity you are getting at either lambda or minus lambda. But maxima you are getting as lambda plus lambda by 2, that is 3 lambda by 2. So maximum point has, that's why we have done that the position of the secondary maxima can be written by this formula, right? I hope you have understood this. Now if you want to find the width, if you want to find the width of the central maxima, so how you will find width of the central maxima? So this is the width of the central maxima, yes or no? So width, so we can write here width of central maxima, central maxima is the distance between, is the distance between first secondary minimum minimum on either side of O. Okay, so this is the width of the central maxima. Now how you will find this here? We know that a sine theta is equal to a sine theta is equal to n lambda. So for first, see here, this is n is equal to 1, and here also n is equal to 1. So for n is equal to 1, so we have a dark fringe or minima point, so that is equal to a sine theta is equal to lambda. So from here sine theta will be equal to lambda by a, right? Sine theta is equal to lambda by a. Now since theta is very small, so we have considered this thing. See here, theta, if we talk about this one theta, we are talking about this theta, we are talking about this theta. So theta is very small, theta is very small, right? So if theta is very small, so sine theta can be written as tan theta, and tan theta can be written as perpendicular by base. So this if you talk about this triangle, so perpendicular by base means y by d. So this is a tan theta. So we have got the values of a tan theta, right? So from here we can write values of tan theta like this. So tan theta is equal to lambda by a, and this is equal to perpendicular, that is y by capital D, y by capital D. So from here y is equal to d lambda by a. But what is the width of the central? See, we have got this y. See, if you observe this, if you observe this figure, so we have got this distance, we have got this distance, right? But we want this total distance of the central maximum, central bright fringe. So you need to find total width of the central bright fringe, right? So if you want to find a width of the central bright fringe, so it will be 2x 2y, width of central bright fringe is equal to 2y, that is equal to 2d lambda by a. Okay, and angular width, if you talk about the angular width, so what is angular width? See, if you want to find angular width, so this is the angular width of the central brightness. See, this is the angular width, this is the angular width of this one, right? So angular width will be 2 theta. So if you want to find angular width, so we can write here angular width is equal to 2 theta. So we can also write here 2 theta, or theta can be written as 2x by d, 2y by d. 2 into theta means y by d. See here, 2 tan theta, and tan theta is equal to y by d, so 2y by d. Got it? Or y is equal to, see here, and y by d is, y by d, what we have considered y by d as a lambda by a. So 2 lambda by a is the angular width. Angular width is equal to angular width is equal to 2 lambda by a. Okay, so I hope you have understood this. I hope you have understood this. So this, thank you.